Hello everyone. Today I want to show you a multi-modal AI system I built that demonstrates how to combine computer vision and natural language processing. The system works with any video content, tutorials, presentations, lectures, and it extracts information from both visual and audio channels, then fuses them together. This is a great example of a multi-modal AI architecture where we are processing different types of data and combining the results. Let me walk you through how it works. First step is selecting a video. I have placed a video file, multiple video files in the photo here. So then the system automatically scans for video files and then lists them here. So for this demo, I will pick one of the video in here. You can see the file name and file size. The analyzer works with standard video formats. Now let's move to frame extraction. Over here, so I can control the frame rate. It sets to zero point 0.4 right now. I can change to 0.5. 0.5 FPS, that means like one frame every 2 seconds. Why frame extraction? Because video is just a sequence of images. By sampling frames at regular intervals, we can analyze the visual content without processing every single frame, which would be computational expensive. The system is using the CV2 video capture to open the video, calculating framing intervals based on the video native FPS, then saving selected frames as images. So perfect, we extracted 43 frames. You can see sample from here, whatever was visible in the video, text, graphs, code, slides. Those became the input for our computer vision pipelines. Now let's move to step 3. The computer vision part. So we are going to use OCR. OCR is a computer vision task where we train neural networks to recognize text in images. I'm actually using the EasyOCR, which uses a deep learning model specifically crafted for text detections and a recognition network for reading the text. So, so what's happening here is like for each frame, the OCR model detects text regions using conver convolutional neural networks, extract those regions, then run character recognition. Each detection gets a confidence score. So I set the confidence score threshold to zero point 0.8. So this filters out low quality detections and reduce false positives. Okay, results it's done in here. So we have a total 43 frames, and we found that 43 frames all have tags, and the 10 key terms are found like unique entities or important terms, and 123 data points like numbers, metrics extracted. So those terms will automatically extract from the video frames. The system uses pattern matching to identify important entities. Could be technical terms, product names, whatever appears on a screen. And here are the numbers that are detected. The system recognizes various formats, percentage, price with dollar signs, common separate values. So this is demonstrates like a Ragus expression matching combined with OCR output. We're not just reading text, we're understanding the structure. Now we analyze the spoken content using NLP. So in production, you can use Whisper AI to transcribe the audio automatically. So for this demo, I'm just using sample transcript. Whisper is OpenAI's speech recognition model. It trained on 680,000 hours of like language data and can transcribe with high accuracy. It's the current state of art for automatic speech recognition. So this is transcript represents what was said in the video. Now we're going to analyze with AI. So this is where large language model shine. GPT-4 model understands context, can extract structured information, and categorize content. So we are making multiple API calls like extract claims, um, analyze tongue, identifying entities. So let's see what it actually found. So it found that in this case, this represents the overall tongue uh, natural. Then it found the zero claims, like zero specific statements extracted from the transcript. And it takes about 13.7 seconds to analyze. So this is like prompt engineering in action. So I crafted specific prompts to get structured JSON output from GPT-4, making it easy to parse and display programmatically. So now let's move to step 5. So now we are reaching the most interesting part, multimodal fusion. So this steps combines the computer vision results and the NLP results into one unified analysis. So um, data, so the data fusion is a key concept in AI system. Like we're taking visual data, like text, numbers, extract from frames via OCR, and then the textual data, like claims entities from GPT-4 analysis, and correlating them to create a richer insights. So, for example, if a OCR detects Python in a frame and a GPT found Python mentioned in the transcript, that's a strong signal that Python is a key topic. So the system also calculates a quality score based on multiple factors on companies of visual evidence, numbers, and type of claims, consistency between visual and text data. So for this one, we got like 65 out of 100. Um, so the quality score, like you should like consider like, does the video have visual evidence, are there verified claims, is the content well structured? So weighting different factors to produce a single metric. Okay, let's view the report. Here's the final analysis, combining everything. So it shows the quality score, the content tone, total claims, and then show the executive summary. So the summary was generated by fusing visual and textual insights. It tells us what the video cover and how comprehensive it is. So like all key topics, tools, and concepts detect both visual and from the transcripts. And the best part is like you can actually download the report entire analysis into a JSON file or Markdown file. So it's like the Markdown is like great for documentation or study guide. So you may ask like, well, could you use this application? So I think the key is like any scenario where you need to extract and analyze information from video content, you can use this. You can try this approach. Mm, it shows like how to build a production quality AI applications that process multiple data um, modalities and present results through a clean web interface. So I'm using Streamlit to create this dashboard for demo. So the code is available on GitHub if you want to explore it further.